Okay, so in this video, we're going to be looking at waves, right? So what is a wave? A wave is a disturbance in a medium that carries energy without the permanent displacement of the particles of the medium. A wave is a disturbance. It is a disturbance in a medium. A wave is a disturbance in a medium that carries energy. So the disturbance in the medium, it carries energy from one point to another without a permanent displacement of the particles of the medium, right? So let me give you a pictorial representation of what a wave is. So here is a pictorial representation of what a wave is. Let's assume that this dot is the particle of the medium, right? The dot is the particle of the medium, or the particles in the medium. Is one of the particles in the medium, right? So a wave, like I said, is a disturbance. It is a disturbance in a medium. This water is a medium. So the water you're seeing here is a medium, right? It's a disturbance in a medium that carries energy from one point to another. So you can see the wave moving, right? From one point to another. It's transferring energy from one point to another. So what is moving in this scenario is the energy, right? So a wave is a disturbance in a medium that transfers energy from one point to another without a permanent displacement of the particles of the medium. So the particles of the medium will still remain where they are, but energy is being transferred from one point to another. So this is what a wave is. So, like I said, a wave is a disturbance in a medium that carries energy without a permanent displacement of the particles of the medium. So here we're going to look at the types of waves that we have. Basically, there are 6 types of waves in physics. We have the mechanical waves, electromagnetic waves, longitudinal waves, transverse waves, standing waves, and progressive waves. So you must know these 6 types of waves. But to get the understanding more, let's look at how these waves are classified. So waves in general can be classified based on the medium of propagation, and under that factor we have 2 types of waves. We have the mechanical waves and the electromagnetic waves. So the mechanical waves, they are the waves that need a material medium for them to travel, while the electromagnetic waves, they do not need a material medium for them to travel for their propagation. So this is a broad classification of waves. Again, waves can be classified based on the medium of propagation, whether they need a material medium for them to travel based on the medium of propagation. Under that, we have 2 types of waves. Mechanical waves, they need a material medium for their propagation or for them to travel. And we have the electromagnetic waves. They do not need a material medium for them to be propagated or for them to travel, right? So mechanical waves can further be classified into 4 types of waves. The first classification is based on the vibration of the particles of the medium. So those whose vibration of the particles of the medium in is parallel to the direction of the travel of the wave, they are known as the longitudinal wave. So if the vibration of the particles of the medium is parallel, so that means if the vibration of the particles of the medium is in this direction, and also the direction of the travel of the wave is in this direction, we refer to that wave as a longitudinal wave. So a longitudinal wave is a wave whose vibration of the particles of the medium is parallel to the direction of the travel of the wave, right? So then we also have the transverse waves, and here the vibration of the particles of the medium is perpendicular to the direction of flow of the wave. So based on this factor, on the vibration of the particles of the medium, we have 2 types of waves, the longitudinal waves and the transverse waves. We're still going to look at this again. So also the mechanical waves can be classified based on the mode of energy transfer or based on energy transfer. Under that, we have two types of waves. We have the standing waves and the progressive waves. Those that do not transfer energy as they travel are referred to as standing waves or stationary waves, right? And those that transfer energy as they travel, they are referred to as the progressive waves. So these are the 6 types of waves that we have: mechanical waves, electromagnetic waves, longitudinal waves, transverse waves, standing waves, and the progressive waves. So let's take the first one, which is the mechanical waves, right? So what is a mechanical wave? A mechanical wave is a wave that requires a medium. It requires a medium for their propagation. That means this wave requires a medium for it to travel. That's a mechanical wave. Such mechanical waves, cannot travel through a vacuum. So because of the fact that they need a material medium, they need a medium for their propagation, they cannot travel through a vacuum. A vacuum simply means an empty space. An empty space where there is no air or there is nothing, right? So mechanical waves, they are waves that require a medium for their propagation. And because of the fact that they need a medium for their propagation, they cannot travel through a vacuum, which is an empty space, right? So the speed of a mechanical wave depends on the medium and the temperature of the medium. So there are two things that determines the speed of a mechanical wave: the medium itself, where the wave travels, and the temperature of the medium. So examples of mechanical waves are water waves, sound waves, seismic waves, and waves on the rope or string. All these requires a material medium for them to travel or for the wave to be propagated. Water waves, for instance, would need water for water waves to be created. Without water, there is no water wave. Sound waves, for instance, will require air for it to travel. It can also require liquid for it to travel. It requires solids for it to travel. So it requires a medium for it to travel. So sound wave is an example of a mechanical wave. Seismic wave is a wave that is due to vibration in the Earth's surface, right? So seismic wave will require the Earth for it to travel. So it requires a material medium. Then waves on a rope or string would require the rope or the string for it to travel. So if there is no rope or string, there is no waves on a rope and string. So all these are examples of mechanical waves. They need a material medium for them to travel. Then the other type of wave that we have is the electromagnetic waves, right? So electromagnetic waves are waves that do not require a material medium for their propagation. So mechanical waves, they are waves that require a medium for their propagation. Mechanical waves are waves that do not require a material medium for their propagation. So for the fact that they do not need a material medium for them to travel, electromagnetic waves can travel through a vacuum. They can travel through a vacuum. So a vacuum, like I said, means an empty space, right? So mechanical waves cannot travel through a vacuum because they require a material medium for their propagation. They need something for them to be able to travel. So they cannot travel through where there is nothing, which is an empty space, which is also called a vacuum. But the electromagnetic waves, they do not need a medium for them to travel. And so they can travel through an empty space, which is what? A vacuum, because they don't need anything for them to travel. Electromagnetic wave, another important thing that you should know is that they travel with the speed of light. And the speed of light is 3 times 10 raised to power 8 meters per second. That's the speed of light. You can be asked this: what is the speed of light? It is 3 times 10 raised to power 8 meters per second. What that means is that light, as soon as you on a flash of light, it can travel a distance of 3 times 10 raised to power 8 meters in 1 second. in 1 second. So electromagnetic waves, they travel with what? The speed of light. Examples of the electromagnetic waves are the radio wave, infrared wave, visible light, microwave, ultraviolet rays, X-rays, and gamma rays. So all these are examples of electromagnetic waves. And why are they electromagnetic waves? Because they do not need a material medium for them to travel. They can travel through a vacuum. So radio waves does not need anything for it to travel. Infrared ray does not need anything for it to travel. Visible light does not need anything for it to travel. Microwave does not need anything for it to travel. And so it can travel through an empty space or a vacuum. Ultraviolet rays does not need anything for it to travel. X-rays does not need any material medium for it to travel. And also gamma ray does not need anything for it to travel. So the catch here is that you should know what the electromagnetic waves are and also know the examples of the electromagnetic waves. So just to buttress more on the electromagnetic waves, like I said, the examples of the electromagnetic waves, they are radio wave, infrared wave, visible light, ultraviolet rays, X-rays, gamma rays, and lastly, we still have another one, which is the microwave, right? So this is a simple acronym you can use to remember these electromagnetic waves. We can use REVOOX, REVOOX, then add M to it to remember the examples of the electromagnetic waves. So the arrow here stands for the radio waves, the I stands for infrared wave, the V stands for visible light, U stands for ultraviolet rays, X stands for X-rays, the G represents the gamma rays, and lastly we have the M, which is the microwave. So you can use this acronym REVOOX, REVOOX M. Okay, so to take us further, let's look at the other type of wave that we have, which is the longitudinal wave. So what are longitudinal waves? Longitudinal waves are waves which travel in a direction parallel to the vibration of the particles of the medium. They travel in a direction parallel. So the main word here is parallel. Such waves travel in a direction parallel to the vibration of the particles of the medium. That's a longitudinal wave. So a longitudinal wave is a wave that travels in a direction parallel to the vibration of the medium. So if the medium is vibrating in this direction and then the wave is traveling in this direction, such wave is referred to as what? A longitudinal wave. Examples of longitudinal waves are sound waves, ultrasound waves, seismic P waves. So sound waves, as I make sound, you hear, right? So it's traveling. So sound waves, they travel longitudinally. Ultrasound waves, ultrasound waves, they are also longitudinal waves. Then seismic P waves, which is waves due to things like earthquake. They are waves that travel on the earth's surface or in the earth's surface. So such wave can be generated by earthquake. Such wave travels longitudinally also to the direction of the vibration of the particles of the medium. So a longitudinal wave, like I said, is a wave that travels in a direction parallel to the vibration of the particles of the medium. So one important thing that you should know in longitudinal waves is that as the wave travels along, there are a series of compressions and refractions as the wave moves along. So the compressions are the path where the waves are close together, while the refraction are the parts where the waves are further apart. It's also referred to as expansion. So let's illustrate that with this diagram. So let's say somebody here makes a sound and then the waves now travels longitudinally, travels in the direction parallel to the vibration of the particles of the medium. So as the wave travels along, There are a series of compressions and refractions as the wave goes along, right? So the area where the waves are closest together, they are referred to as what? The compression. While the area where the waves are further apart or furthest apart, they are referred to as what? Refraction. So here is refraction, here is the compression. Here is compression, refraction, right? So the point where the waves are close together, the waves is very concentrated there. So the point of refraction, the wave is not very concentrated. So let's say if this person C makes a sound, it's more likely that the person at B will hear more than A. Why? Because the waves is more concentrated here. Even though B is in a farther distance from C, B will still hear more better because the waves here they are more concentrated than the waves in A, which is the point of refraction or area of refraction. So that's that for the longitudinal waves. Then let's look at the transverse waves. So transverse waves, they are waves that travel perpendicular to the vibration of the medium. They travel perpendicular to the vibration of the medium. So let's say if the wave, the vibration of the particles of the medium is in this direction, and then the wave is traveling in this direction, we can say that such wave is what? A transverse wave, because the wave is traveling perpendicular to the vibration of the particles of the medium. Examples of transverse waves, they are water waves, vibration in a guitar string, that's waves in a guitar string, then seismic S waves, right? Then we also have the electromagnetic waves. So all electromagnetic waves, they are transverse waves. So transverse waves, examples are the water waves, vibration in guitar string, seismic S waves, and the electromagnetic waves. And like I said, you can use the acronym ROIVUXGM to remember the examples of the electromagnetic waves. REVOX M. R is for radio waves, I is for infrared light, V is for visible light, U is for ultraviolet rays, X is for X-rays, G is for gamma rays, and M is for microwaves. So the next type of waves that we have here is the progressive waves. And the progressive wave is also known as traveling wave. So what does that tell you? That it is a type of wave that transmits energy as it travels from one point to another. So it transmits energy as it moves from one point to another. All longitudinal and transverse waves, they are examples of what? Of progressive waves. Then we have stationary wave, also known as the standing wave. So a stationary wave is a wave that does not transmit energy as it travels. It's a wave that does not transmit energy as it travels. So it is the opposite of the progressive waves. So two waves of the same amplitude and frequency traveling in opposite direction will create a standing wave. So for example, this is a wave, right? This is a green wave traveling in this direction. If a similar wave, like this blue one, is traveling in the opposite direction and is having the same amplitude and frequency as the previous wave, a standing wave, also known as a stationary wave, will be produced or will be formed. Examples is waves in a guitar string. So as you pluck a guitar, a wave travels in this direction. As it hits the bar of the guitar, it creates another wave that travels in the same amplitude and frequency as the previous one. And so it will bring down the wave, creating what? A stationary wave. So in this wave, there are 2 points that you must note. We have the node in which there is no displacement, and you have the antinode where there is maximum displacement, right? So you must note these 2 points. So just a quick recap, we've looked at what a wave is. We've looked at the different types of waves. Like I said, a wave is a disturbance in a medium which transfers energy without permanent displacement of the particles of the medium. And then we classified waves. So, like I said, waves are classified broadly based on the medium of propagation. Those that need a medium for them to travel, they are known as mechanical waves. Those that does not need no medium for them to travel, they are known as the electromagnetic waves. Then the mechanical waves are further classified into four types of waves. So the first classification is based on the vibration of the particles of the medium. There we have the longitudinal wave and the transverse waves. So if the direction of the travel of the wave is parallel to the vibration of the particles of the medium, we call that a longitudinal waves. And we looked at various examples. Then if the direction of the travel of the wave is perpendicular to the vibration of the particles of the medium, we refer to that as a transverse wave. And we looked at the examples as well. Then based on energy transfer, we have standing waves and progressive waves. Those that does not transfer energy as they travel, they are referred to as standing waves, and those that transfer energy as they travel are referred to as progressive waves, right? Okay, so to take us further, let's look at some questions. So the first question I have here is, which of the following is not a mechanical wave? Which of the following is not a mechanical wave? So a mechanical wave is a wave that requires a material medium for it to travel. So sound wave, it requires a material medium for it to travel. So sound wave is a mechanical wave, right? It requires air, it requires water, it requires solids for it to travel. Then we have microwave. So microwave is not a mechanical wave. So our answer is microwave. Microwave is an example of an electromagnetic wave. Electromagnetic wave. Why? It is electromagnetic because it does not need a medium for it to travel. So the electromagnetic waves that we looked at, they are RIVUXGM. So R is for the radio wave, I is for infrared wave, V is for visible light, U is for ultraviolet rays, X is for X-ray, G is for gamma rays, and M is for what? The microwave. So microwave is an example of an electromagnetic wave. So which of the following is not a mechanical wave? Microwave is not a mechanical wave. Which of the following is not a type of wave? So electromagnetic wave, yes, it is a type of wave. Mechanical wave, yes, it is a type of wave. Longitudinal wave, yes, it is a type of wave. Electric wave is not a type of wave. So the correct answer to this question is what? Option D. Which of the following is not a type of wave? Electric wave is not a type of wave. Wave that travels through a stress string is known as, so this is a 2013 JAM question. Wave that travels through a stress string is known as, so A, we have the electromagnetic wave, we have microwave, mechanical wave, seismic wave. Waves that travel through a stress string, they are known as what? The mechanical waves, because they need a material medium for them to travel, which is what? The string. Which of the following waves is both transverse and mechanical? So which of the following waves is both transverse and mechanical? So is it water waves? Is it the radio wave? Is it sound wave? Is it X-ray? So water wave is an example of a transverse wave. It's also an example of a mechanical wave, right? Radio wave is an example of a transverse wave, and it is an example of an electromagnetic wave. It is not a mechanical wave. Sound wave is an example of a longitudinal wave. It's an example of a longitudinal wave, and it's also an example of a mechanical wave. because it needs a material medium for it to travel. S3 is an example of a transverse wave. It's transverse and is electromagnetic as well. So which of the following wave is both transverse and mechanical? So the correct answer is water wave, option A. So water wave is transverse, is also what? Mechanical. Which of the following statement about wave motion is correct? Electromagnetic waves are transverse waves. Yes, electromagnetic waves are transverse waves. Transverse waves do not require a medium for their propagation. This is wrong because some mechanical waves like water wave, it requires a medium for it to travel. So this is a wrong statement. Then longitudinal waves vibrate perpendicular to the direction of travel. No, they vibrate parallel to the direction of travel. So this is a wrong statement. All mechanical waves are longitudinal waves. This is a wrong statement as well. So electromagnetic waves are transverse wave is the correct statement here. So if we go back to that transverse waves, like I said, transverse waves are waves that travel perpendicular to the vibration of the medium, right? So like I said, all electromagnetic waves are what? They are transverse waves. They are transverse waves. So let's look at this last question. The above figure shows the motion of a progressive wave. A progressive wave. So the above figure shows the motion of a progressive wave along a string. The particle motion of the medium is in direction. Is in which direction? So the direction of the particles of the medium doesn't really change, right? Energy is just transferred, but the direction of the part there is no permanent displacement of the particle motion of the medium or the direction of the all the particles of the medium. There is no displacement of it. There is no permanent displacement. So if we go back to that diagram that I showed you the other time, so if this dot is the particles of the medium, right? The medium is transferring energy as it travels. It's transferring energy as it travels, but the particles of the medium remains where it is. There is no permanent displacement of this medium. So you can see that it's just moving up and down, up and down, up and down, up and down, just like that, right? So A is parallel to OX. Is it going to move parallel to OX? That's wrong. Parallel to OY. Is it going to move parallel to OY? Yes. It's just going to move up and down, up and down, up and down. There is no permanent displacement from that particular what? Position. From that particular position. So the correct answer is parallel to OY. The figure above shows the motion of a progressive wave along a string. The particle motion of the medium is in the direction parallel to what? OY, which is what you've seen. So with this, we come to the end of today's lesson. Thank you very much for listening.